Okay. What's the total charge on the right-hand side? Left-hand side, sorry. No. Would you believe 12?
Total charge would be 30.
There's 14, no, just the left-hand side. There's 14 positive charges, 2 negative charges.
Well, that's a 2. That changes so
Well,
much.
it's dichromate, of course it's a 2.
I know, that's what I was thinking. I was thinking, why is it wrong?
Dichromate has to be a 2, doesn't it? Yeah. That's not like you're not used to my bad handwriting anyway, but. Alright, so total charge on this side is, what do we say, plus 12? On that side it's plus 6. What do we have to do to balance by charge? No, we're not multiplying yet. Balance the charge first. We got to add electrons to this side. Is that right? So 6 electrons. All right, let's check in our math here. That's a minus 6, minus 7, minus 8. And then plus 14 gives us a total of plus 6. This is 2 times 3 plus, which is plus 6. This half reaction is balanced. Balanced by mass, balanced by charge. We're done with that half of it. With me so far?
Yep.
Wait, just that last thing. The coin distracted me. I'm sorry, just that last thing where the 6 electrons came from.
Hey, just because I have a short attention span, that doesn't mean... What were you saying? Sorry. Okay, so if we just had the dichromate and the 14H plus, the total charge on this side is plus 12.
Plus 12, got it. Why 6 minus 12 balances it out?
Huh?
Why is
This is 14 plus, this is 2 minus.
okay, so you get...
So this was plus 12, this was plus 6. If we had 6 electrons here, this is now plus 6, that's now plus 6.
But why is it plus 14?
Because we had to add 14 hydrogen ions to balance out those 7 waters we put in.
So why don't you multiply, like, we have our electrons type on that 14.
Do the electrons very last.
Very last.
Very last in a half reaction. Balance the mass first, then balance charge.
I see that.
Okay? All right. Next up we have our other reaction, which was Cl minus goes to form Cl2. And this one's oxidation, right?
Yes.
Okay. Let's designate that maybe. This one's the reduction reaction. This one's the oxidation reaction. Okay, what do we need to do to balance by mass?
Balance by mass?
Yep.
You have to get 2.
Two
chlorides.
2 chlorides would make up a single chlorine molecule. Good. Now the good news is on this particular step, we don't have to worry about oxygens or hydrogens because there aren't any. So what do we have to do?
Add electrons.
Got to add electrons to balance the charge. So the left side has a total charge of what? And the right hand side has
0.
0. So where do we put the electrons?
Right side.
Right side. Okay? This half reaction is now balanced by mass and charge. Two chlorines, total minus 2 charge, total minus 2 charge. All is well. Now, our next step is to add those two together. No, it's not. What do we have to do first? We have to balance these two things with respect to each other based on the number of electrons. So, the reduction half reaction consumes 6 electrons. The oxidation half reaction produces 2 electrons. Is it fair to say that the oxidation reaction is always going to produce electrons?
Yes.
Yeah.
And the reduction half reaction is always going to consume electrons? That pretty much fits our definition, doesn't it? So, what do we do to make that happen? We've got 6 here, and only 2 there.
Well, you go to the least common multiple. Or
Least common multiple, which in this case is 6.
6.
So let's just multiply everything here by 3.
It's not 12.
So that becomes 6. That becomes 3. That becomes 6. Okay? Is that good? Now we can add them together. And let's cancel anything that appears on both sides. Okay? So what appears on both sides? If we have done this correctly, we will always be able to cancel the electrons. Every single time. Because that's the whole point of getting to this point, is so that we can cancel the electrons. Okay? So, 6 electrons on this side, 6 electrons on that side, they cancel. What else is left? Well, on that side we have dichromate. So Cr2O7, 2 minus. Let's maybe underline that to identify that we've dealt with it. Plus, what else is on this side? 14 hydrogen ions. Okay, so let's underline that. What else do we have on this side? 6 chlorides. Okay? Anything else on the left-hand side? Nope. All right. So we can draw our other arrow in there. What have we got on the right-hand side now? 2, what's this ion called? Chromium 3. And we also have 7H2O and we should identify that as a gas probably, which is what that's supposed to say, but it doesn't look real good. Okay? Now, let's verify that we do in fact have the same thing on both sides. Let's do mass first because it's easiest. Chromium, 1, 2 on that side, 1, 2 on that side. Oxygen, 7 on that side, 7 on that side. Hydrogen, 14 on that side, 7H2 makes 14 on that side. Chlorine, 6 on this side, 3Cl2 makes 6 on that side. This is balanced by mass. Now, what is the total charge? Okay? Dichromate ion is -2. 6 chlorides takes that down to -8. 14 hydrogen ions brings it up to +6. The only things we have on this side with a charge are the 2 chromium 3 ions. That's a total of +6 charge. This is balanced by charge. If this is balanced by mass and by charge, this is the balanced chemical reaction. We are done.